Hello, I am Seema and welcome to part 12 of the chapter Redox Reactions. In the previous two parts, I have been explaining how to balance chemical equations using the first method, which was the oxidation number method. In this video, I'm going to explain the second method of balancing of chemical equations, and that is the half reaction method, which is also known as the ion electron method. If you do not understand what oxidation number method is, I would encourage you to watch those videos first, because that gives you a little basis of how to balance a redox reaction. Now, this is an entirely different method, but the two methods are basically, what are you doing in the two methods? You're balancing the equation. So they do have similarities, very little, but the basic method, the steps are different. But the basic ideology is the same, that the number of atoms and the charges on both the sides should be equal in the end, however you approach it. Let us now understand the steps of balancing a redox reaction with the help of half reaction method. As the name suggests, half reaction method, you divide the reaction into halves, and that is why. And what would the two halves be? Since we are talking of redox reactions, the two halves would be oxidation half and the reduction half. So let us see, how do we approach this? The first step is to produce unbalanced equation in ionic form, or to write down the equation. All formulae of all reactants and products should be correct. The only condition is that they should be in the ionic form, because reduction and oxidation, you would be able to balance it only if you know the charges of the ions. Therefore, you will write the ionic equation first with all the reactants and the products. At least those species which got oxidized and reduced should be there. Then what do? You identify the species that is oxidized and identify the species that is reduced. And you separate the two halves. You separate that species which got oxidized, and what did it get oxidized into? The species that got reduced, and what did it get reduced into? So we get two half reactions, the oxidation half reaction and the reduction half reaction. In the next step, what do? We balance all atoms other than oxygen and hydrogen. So we just take all atoms, or basically when you, other than oxygen and hydrogen, the species that you have, the one that got oxidized or reduced, those are the ones that you will be balancing first. So all atoms or all elements, atoms of elements which are not oxygen or hydrogen are balanced. After this step, if the reaction is taking place in acidic medium, then we add water. In oxidation number method, we balance hydrogens and oxygens in the end. And we do it if it is taking place in acidic medium, we know we add H positive, and if it is taking place in basic medium, we add OH negative. But after adding the H positive and OH negative, the oxygens are balanced by adding water molecules. In this case, in the half reaction method, we follow the opposite approach. We will be balancing acidic medium with hydrogen ions and basic medium with OH negative ions, but we will be doing it after putting in water. So we'll put in water molecules first. So for the reaction in acidic medium, we will first add water molecules to balance off the oxygens. And once the oxygens are balanced off, then on the basis of that total number of oxygens, you will add H positive. And obviously it will be on the other side, and you will be adding OH negative on the appropriate side if it is basic medium. So if it is acidic medium, you will add H positive. If it is basic medium, you will be adding OH negative. So I'll explain the fourth step once more. What do we do in this method? We first balance oxygens. And how do we balance oxygens? By adding water molecules. And once the oxygens are balanced, then we count the hydrogens. And if it is acidic medium, we put those many hydrogens on the opposite side, hydrogen ions. And if it has hydrogens and you have a basic medium, then instead of adding those many number of hydrogen ions on the opposite side, you add OH negative ions on both sides of the reaction. That is on the reactant side as well as the product side. And then if you do that, you will realize that one side will have the H positive ions, and you added OH negative ions. When you add OH negative ions to both the sides, the side that has H positive ions, the OH negative ions and H positive will combine to form water molecules. So it will give you additional water molecules in that case. And the OH negative would be on the other side. I'll explain this better when I solve problems in both acidic and basic mediums with you. So this was the fourth step. What do? We first balance oxygen using water, and then we balance hydrogens using H positive, and if it is an acidic medium and if it is a basic medium, we add OH negative to both sides. Adding OH negative, it is only OH negative which is added to both sides. H positive is added only to the opposite side of water. In the next step, now we have already balanced hydrogen, we've balanced oxygen, we've balanced all atoms other than hydrogen and oxygen, which means all elements have been balanced. The next step would be to see the charges on both the sides. So in order to balance charges, in the case of half reaction method, we use electrons. So we balance charges with the help of electrons. So whichever side is more positive, one of the sides will be less positive or will be more negative. You will add electrons to the side which is more positive. Those many electrons, the difference, you will add those many electrons on that side, and thus you will balance the charges of the two sides in both the half reactions. Remember what we did in the second step? We separated the equation into two half reactions. The remaining steps you're going to carry out for both the half reactions. So you are simultaneously balancing both the halves. So you add electrons to balance charges, and you make electrons on both half reactions. Now, remember, in reduction and oxidation, the number of electrons lost should always be equal to the number of electrons gained. So the electrons in both the half reactions, whatever is getting oxidized or reduced, the number of electrons should be the same. In order to do that, that half reaction which has lesser number of electrons, you will multiply the whole reaction with that stoichiometric coefficient, which is the difference between the number of electrons. Thereby you will multiply not only the electrons, you will multiply the entire equation, reactants and products, by that number. And now that the number of electrons is equal in both the half reactions, the atoms are all balanced, now you will add the two half reactions. When you add the two half reactions, you know oxidation is loss of electrons and reduction is gain of electrons. So in the oxidation half reaction, you will get the electrons in the products, because they are losing electrons. And in the reduction half reaction, you will get electrons in the reactants. So the electrons will get cancelled out. And since you made sure that the electrons are equal, the electrons will get cancelled out. And in the overall reaction, you will get the reactants and the products, and what got oxidized, what got reduced, and water molecules in order to balance out the hydrogen and oxygen. And you will get a balanced equation. Minus, of course, the electrons, which actually should not be there. The electrons we add only to understand how many electrons were, to rather equate them, to make sure that the number of electrons lost is equal to the number of electrons gained. So let us solve this. After you add the two half reactions, you will be cancelling out the electrons, and in the last step, which is the seventh step, you'll verify all atoms on both the sides and check that the charges are also balanced. So let us take this first example, which is given in the textbook, as it was solved to explain the steps. Balance the equation when Fe2 positive is oxidized to Fe3 positive by dichromate ions, that is Cr2O7 2 negative ions, which are reduced to Cr3 positive. So what is the first step? First step is produce the unbalanced equation in ionic form. We've been given the ions, so let us write down the ions. Fe2 positive was present, and it was oxidized by dichromate ion, that is Cr2O7 2 negative. Will give you Fe3 positive plus Cr3 positive. So this is the ionic equation that you have got. You have the ions on both the sides, the reactants and the products. In the next step, what do? You separate the equation into oxidation half and the reduction half. We know that iron, Fe2 positive, usually, a reaction would be given to you and they may not be telling you what is getting oxidized, what is getting reduced. So here the steps would be the same as the oxidation number method. You will identify the oxidation number of allot oxidation numbers to every atom, identify what got oxidized, what got reduced. So let us assume that we did not know what got oxidized and what got reduced, and let us write down the oxidation numbers. Fe2 positive has a charge of +2. Fe3 positive has a charge of +3. So oxidation number is increasing, therefore Fe is getting oxidized. So your oxidation half reaction should have these two. In Cr2O7, 7 oxygens means there are 14 negative charges. Each oxygen has 2 negative charges. And the species on the whole has got 2 negative charges, which means that out of 14, 12 charges have been cancelled, or there are 12 positive charges being supplied by chromium. And therefore, how many atoms of chromium are there? There are 2 atoms of chromium. So one atom must be giving how many electrons? Out of 12, one chromium must be giving 6 electrons. Therefore, the charge on chromium here would be +6. And in Cr3 positive, the charge on chromium is +3, which means the oxidation number of chromium is decreasing and therefore this is getting reduced. So your reduction half reaction should have this species and its product, and the oxidation half reaction should have this species and its product. So now we will divide the equation into 2 half reactions, that is the oxidation half and the reduction half. So let us write down the oxidation half. In the oxidation half, I'll get Fe2 positive will give me Fe3 positive, right? And in the reduction half, what do I have? I have Cr2O7 2 negative will be giving me Cr3 positive, right? Now I have divided my equation into 2 halves, the oxidation half and the reduction half. In the next step, you have to balance all atoms other than oxygen and hydrogen. Now, in this, we have iron, and in this we have oxygen. So it is only oxygen and hydrogen which have to be ignored. So let us see, in the case of Fe2 positive, Fe3 positive, the number of iron atoms on both the sides is equal. So this is already balanced. In this case, you have 2 chromiums in the reactant side, but there is only 1 chromium on the product side. So you'll multiply chromium. You got the chromium, that is all atoms other than oxygen and hydrogen are now balanced. You balanced chromium in the reduction half and you balanced iron in the oxidation half. Now after this has been done, what is the next step? You balance all atoms other than hydrogen and oxygen for reactions in acidic medium. Now this reaction is taking place in an acidic medium. You have to add water molecules to balance oxygen atoms, right? This reaction is taking place in acidic medium. So what do? You first balance the oxygens by adding water. In this equation, in the oxidation half, you do not have oxygen. So there is no need to add water molecules. But in Cr2O7, you have 7 oxygen atoms here. Do you see? There are 7 oxygen atoms and there is no oxygen on the other side. So you have to balance the oxygens by adding water molecules. Obviously, you will add water molecule to that side, which is the other side, other than if you have oxygen in the reactant, you will add water in the product. If you have oxygen in the product, you will be adding oxygen in the reactant. So here you have 7 oxygens. I'll add how many? 7 water molecules. That is 7 oxygens have now been balanced. After balancing 7 oxygens, I now have to balance the hydrogens which have been put in due to the water. So how many hydrogens are present now? 7 twos are 14. There are 14 hydrogens which need to be balanced. So I'll balance the 14. How can you have equal number of hydrogens? If you have 14 hydrogens in the product, you need 14 hydrogens in the reactant side in order to balance it. So I will add 14 hydrogen ions because it is acidic medium. If it was a reaction that was taking place in basic medium, the steps till now would have been the same. Only now, in order to balance out the whatever is the number of make H positive an equal number of OH negative ions on both sides. What would I have done if it was a basic medium? I would have added the 14 hydrogens to this side, and then I would have added 14 OH negative ions to this side and 14 OH negative ions on this side. And then the hydrogen and the OH would have formed water on this side, and then I would have cancelled out the water. Do you get me? So when it is basic medium, the steps are the same, only you need to add OH negative ions in the same number of OH negative ions as the H positive ions, but OH negative ions have to be added to both the sides, right? So you will add OH negative, an equal number of OH negative ion to both sides, make H positive and OH negative into water. That is in case of basic medium. We'll take another example and then I'll explain that. So right now we have got 14 H positive ions. Now we have to see the charges on both the sides, and atoms have been balanced, hydrogen and oxygen has been balanced. Now we need to balance the charges. And in order to balance the charges, we need to use electron. And that is why it is also known as the ion-electron method. You use the ionic equation and you use electrons to balance the charges on those ions. Therefore, this method is also known as the ion-electron method. So let us now use electrons. You have Fe2 positive and Fe3 positive. This is more positive. What is the difference? This has 2 positive, this is 3 positive. 1 positive is extra. So if you add 1 electron here, this will also become 2 positive and this is 2 positive. So since you can balance only with electrons, you will add 1 electron to this side. Right, in the next step. After adding 1 electron, now the charges have been balanced in iron. But in the reduction half reaction, let us see what are the positives and the negatives now. Here you have 14 positive charges and 2 negative charges. It means you have 12 positive charges, right? There are 12 positive charges, and here you have 3 positive and there are 2 chromiums. So you have 6 positive charges. So you have 6 positive charges in the product side, but 12 positive charges on the reactant side. That side which has more positive charge, you will add negative charge to that side to make it equal. So how many negative charges should I add on this side in order to make it equal to 6? I will have to add 6 electrons. So on the reactant side, I will add 6 electrons. Now on adding 6 electrons, out of 12 positive charges, 6 positive charges have been cancelled, and now you have 6 positive charges on this side and 6 positive on the other side. Therefore, your positive charges are balanced. The charges are also balanced. So we've reached that step. But then, what is a redox reaction? In a redox reaction, the number of electrons lost has always got to be equal to the number of electrons gained. So, the number of electrons in both the equations should be equal. In oxidation, 1 electron was lost, but in reduction, 6 electrons were gained, which is not possible. So we have to, in order to make them equal, I will have to multiply this entire equation by 6. So this becomes into 6, so I get 6 Fe2 positive will give me 6 Fe3 positive plus 6 electrons. Now this is my oxidation half reaction, where the number of electrons also in both the oxidation half and reduction half are equal. And then we come to the next step, that will be adding the 2 half reactions. So you will add the 2 half reactions. Let us add them. Let us see the reactant side. What all do you have? You have 14 H positive plus Cr2O7 negative plus 6 Fe2 positive. And the 6 electrons in the oxidation half and the 6 electrons in the reduction half would get cancelled. So we can ignore these. And what will you get in the products now? You'll get in the products, you get 2 Cr3 positive plus 7 H2O plus 6 Fe3 positive. Right? So this is your balanced equation. And And now in the next step, I'll just step out. You can count all the atoms, pause the video here, count all the atoms and all the charges on both the sides. They should be equal. Now I'll write the next question. Give me a moment. Okay, now this is question 8.10. It is a solved example of your textbook. Let us solve this. What does the question say? It says, permanganate ion, that is MnO4 negative ion, in basic solution oxidizes I negative ion to produce I2 and MnO2. You have to balance this equation. So let us first write down the ionic equation in the first step. Produce unbalanced equation in the ionic form. You have MnO4 negative plus I negative to give us I2 and MnO2. So let us write down the oxidation states of all atoms. You have manganese and iodine. In MnO4 negative, the whole species has a negative charge. 4 oxygens have 8 negative charges, out of which 1 is not balanced by a positive charge. So you're left with 7 negative charges, which are balanced by 7 positive charges, and those 7 positive charges are being supplied by manganese. Therefore, this would be, manganese would be plus 7. And in MnO2, what would manganese be? This is neutral, 2 oxygens, so 4 negative charges, and therefore manganese has 4 positive charges, so the oxidation number is plus 4. In I negative, the charge on iodine is 1 negative or negative 1, and in I2 it is 0. So what is getting oxidized? What is getting reduced? Let us identify. Manganese is turning from plus 7 to plus 4. That is, its oxidation number is decreasing. If oxidation number is decreasing or reducing, it is undergoing reduction. So this is the reduction half. Iodine, on the other hand, the iodide ion is turning into iodine. So it is turning from -1 to 0. It means the oxidation number is increasing. Therefore, this becomes the oxidation half. So let us write down the half reactions in the next step. First step, produce balanced equation, identify what got oxidized, what got reduced. Separate equation into oxidation and reduction halves. Let us separate them now. The oxidation half and the reduction half. Oxidation half is iodine will give you I2, right? And reduction would be MnO4 negative will give you MnO2. So we've got the oxidation half and the reduction half. Next step is to balance all atoms other than oxygen and hydrogen. So you have iodine, there are 2 iodines here and 1 iodine here, so I'll balance iodine. Here I have to balance manganese, and manganese you have 1 here, it is already balanced. So now this step is also done where we have balanced all atoms other than oxygen and hydrogen. Now in the next step, we have to balance oxygens by adding water molecules. We have oxygens here. You have 4 oxygens on this side and 2 oxygens on the other side, right? And remember, this reaction is taking place in basic medium. So we'll be using OH negative here. So you have 4 oxygens here and 2 oxygens here. You need 2 more. Therefore, in order to add 2 more oxygen atoms, you'll add 2 water molecules, right? When you add 2 water molecules, the hydrogen atoms have to be balanced by adding H positive. So there are 4 hydrogens on this side. Therefore, I'll have to add 4 hydrogen atom ions on this side in order to balance the hydrogens. Now, since the medium is basic, I need to add OH, this equal number of OH negative ions on both the sides. So I'll add 4 OH negative ions on this side and 4 OH negative ions on this side, right? When I do that, I now have to convert the OH and H positive, they get together to form a water molecule. So this will result in the formation of 4 water molecules. So I'll get 4 water molecules plus MnO4 negative, MnO2 plus 2H2O plus 4OH negative. Now what do I notice? I've got water both in the reactant side and in the product side. So you cannot have water on both the sides, you know. So I'll find out the difference and I'll see some of it will be cancelled. There are 4 water molecules on this side and there are 2 water molecules on this side. So the 2 water molecules will get cancelled and you'll be left with only 2 water molecules on this side, right? So now I have used water molecules, I've used OH negative, and I have taken care of the basic medium. So what step has been done? 4th step is done. For reactions in acidic medium, add water molecule to balance the oxygen atoms, we did that, and H positive to balance the hydrogen, we did that. For basic medium, you do as above, and then for each H positive, you have to add an equal number of OH negative. So we had 4 H positives, we added equal number of OH negatives on the both sides. Then in the side where you have H positive and OH negative, you turn them into water molecules and then balance the water molecules. This step is also done. Now we have 2 half reactions and the next step is to balance the charges of the ions, because we've balanced everything. We've taken care of reduction of oxidation, we've taken care of identification of reduction and oxidation. And then we took care of the atoms other than oxygen and hydrogen. Then we took care of oxygen and hydrogen. We took care of the medium, whether it was acidic or basic. In the next step, in order to balance charges, we have to add electrons. So let us come back to both the reactions. On this side, what are the charges? You have 2 negative charges, and on this side you have a 0 charge. In order to make them equal, what will you do? You will add 2 electrons here, right? When you solve these, try to put a line in between so that it becomes easier for you to know which is the oxidation half and which is the reduction half, so you don't mix up the reactants and products. So you add 2 electrons. Now there are 2 negative charges here, 2 negative charges here. Oxidation half is balanced, like the charges are balanced. Let us come to the reduction half now. Here you have 1 negative charge and here you have 4 negative charges, right? In order to balance the charges now, you need 3 electrons on this side. So 1 negative, if you add 3 electrons to this side, the charges will get balanced. With 3 electrons, yeah. With 3 electrons, you get 3 electrons, 3 negative plus 1 negative will be 4 negative charges is equal to 4 negative charges. So you've done that. Now you have to make the number of electrons in the oxidation half equal to the number of electrons in the reduction half. Because in redox reactions, the number of electrons lost should always be equal to the number of electrons gained. You know, at this step, there is one thing that you can always verify. Oxidation is loss of electrons. So in the oxidation half, electrons will always be in the product. And in the reduction half, it is gain of electrons. So electrons are a reactant in that case. So they should always be on the reactant side. So this is just, it'll give you a little idea that when you're solving the equation, you're going correct. Now, in order to make them equal, whenever you have these 2 numbers, 2 and 3, the easiest way to balance them is, both of them are prime numbers. You will not have a common multiple. You will not be able to make them equal otherwise. So the best way is multiply this by this and this by this. So when you have 2 and 3, multiply this equation by 3 and multiply this equation by 2. So let's do that. Multiply this equation by 3 and multiply this equation by 2. And then write the final oxidation half and the reduction half. So, and I'll write them on top and bottom this time. So this will, if you multiply this by 3, 3 2s are 6 iodide ions will give you 3 iodine plus 6 electrons. Then reduction half will become 3 2s are 6 electrons plus 2 2s are 4 water plus 2 MnO4 negative will give you, again multiply, 2 MnO2 plus 4 2s are 8 OH negatives, right? So now you have multiplied the reduction half by 2 and you have multiplied the oxidation half reaction by 3. Now we have to add the two equations, the two half reactions, to get the final reaction. And when you add these two half reactions, the electrons in the product and 6 electrons in the reactant, they will get cancelled out. And whatever is left will become your equation. So you can always, when you're writing down the reactants and products, you must put the water and the OH negative, you can try and put them in the end. So, and the other reactants can be put before it. Now, it makes no difference. You can always write them as they are, but that makes it easier because you'll always look for the reactant, the reduction part, the oxidation part, and then the acidic part. So I'll write 6H negative, 6I negative here, plus twice MnO4 negative plus 4 water molecules will give me 3 iodine molecules plus 2 MnO2 plus 8 OH negative. So this is the equation that I get. And let us balance all the atoms. There are 12 iodines here, 3 iodine. Yeah, this is not, this is iodide ion, sorry. Made a mistake here. It's not iodine, that's what I'm wondering. 6I negative. So there are 6 iodide ions, or 6 iodine atoms, 6 iodine atoms on this side, 2 manganese, oxygens we'll see in the end. 4 2s are 8, H plus 4, 12 oxygens here. 2 2s are 4, 4 plus 8, 12 oxygens here. How many hydrogens? There are 8 hydrogens, and you have 8 hydrogens on this side. So the equation is balanced. Now if you look at the charges, you have how many? 6 negative, 6, 7, 8 negative charges. And take a look here, you have 8 OH negative, that is 8 negative charges on the other side. So both the atoms and the charges are balanced. I'll step out, you can do it on your own for a moment. So I hope the ion electron method or the half reaction method is clear to you now. With this, I'll wind up today's video. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.